Sketch a quick graph and state the components. First, you should be able to notice that x is the exponent, so therefore there will be an exponential growth or an exponential decay. To determine, we're looking to see what value is being raised to the power of x. In this case, it's 4. If it's greater than 1, we know it's going to be an exponential growth. If it's less than 1, as you multiply numbers that are less than 1 over and over again by themselves, becomes a smaller, so it'll be a decay. And I'm just going to make a quick graph. I'm just going to plug in values for x and y. I'm going to plug in a 0. If I plug in a 0, 4 to the 0 power gives me 1. Plug in a 1, 4 to the first power gives me 4. 1 and 4. Plug in a 2, 4 to the second power gives me 16. And I'm not able to graph it. Remember, this case, this graph is not being shifted. There's no h and k. So here's your asymptote. And it's going to be a growth. Now, domain. The domain corresponds to the x values. So if I look at the graph, I'm not going to be able to see a graph over here. Yes, that graph continues, so it'll be from negative infinity. And if I go over to the right, I'm able to see a graph. I still have a graph. Even if I stand over here, the graph will be way up there, but still there. So therefore, your domain will be from negative infinity to positive infinity, or all real numbers. Your range are your y values, and at what point do I start seeing the graph? So starting from 0, I see a graph all the way to positive infinity. So from 0 all the way to positive infinity, or you can also say all the values are greater than 0 as well. Your asymptote. Your asymptote is a dashed line. And to find the equation, remember that if it's a vertical line, is x equal to a number. If it's a horizontal line, it's y equal to a number. In this case, this is a horizontal line, and it's crossing the y-axis at 0. So therefore, the equation is y equal to 0. And that's a quick sketch.